All right, welcome. This is week 28 homework solution. This is for IM2. Here we have Tuesday, February the 11th. Here you're going to state the domain in three ways: in your inequality, your set notation, and your interval notation. Please understand interval can also mean bracket. Okay? So, let's just write this out so you can see what I'm referring to, okay? Or what it looks like. The inequality looks something like this, okay? Something like that. Okay. Okay. Something like this, or y for the range. Look something like that. Your set notation will look something like this with the fancy bracket, your x, the bar. Then you have your inequality here. Then your y looks the same thing, but now we use the letter y. And your interval notation, let's make that red, blue, purple. No, let's make that green. Okay, your interval notation could either look like this with this, or parentheses, parentheses, or brackets. Okay, that's what it means. Okay, so these are the three things. That's interval in green, blue, that's your set notation. Your red is going to be in your inequalities. Okay, we're going to state the domain and range those ways. Okay, just more practice on domain and range. Okay, here's your inequality. Okay, set notation, interval notation. Okay, I just wrote it out. Okay, just to save us time. Okay, but you don't have this on your paper, you just have to write it. Okay, so the first one, domain, we're going to use in red. So we're going to do the domain first. Remember, the domain is your x value. Okay, all right, so what is the inequality? Domain, we are looking from what? Left and right. So we go left. Does it tell us to stop? Nope. Tell us to what? Keep going all the way to what? Negative infinity. And we go to the right. Does it tell us to stop? Nope. It tell us to keep going. Goes all the way to positive infinity. So what is the inequality? Negative infinity. Okay. We have x all the way to positive infinity. And we put that inside the brackets. Okay. This means x is less than infinity, but greater than negative infinity. In set notation, we put the fancy bracket, we put the letter, which is going to be x, we put the bar, then we grab this inequality. All right, so just grab this inequality. So I'm just going to copy it here, paste it in right there, then finish it up with the bracket. I'm done. Now I go to interval notation. What is this? Okay, here, some things that you might not see. This, if it looks like this, it means it is open parentheses. But if it's greater than or equal to, that is the bracket. Okay, likewise, the less greater than looks like that. Greater than or equal to is a bracket. So here, do you see how it's just x is greater than negative infinity? So it is open parentheses at negative infinity, comma, goes all the way to positive infinity. You don't have to write the positive. If you don't write the positive, it's assumed that it's positive infinity. Do we have this as a bracket or parentheses? It would be a parentheses. Remember, it has to be open. You cannot close it in a bracket. You cannot close down infinity. Okay? Oh, did I do this in different colors? Was I supposed to do this in different colors? Oh, yeah. My bad. My bad. Um, uh, let's see. This should be. Okay. So, my bad. I decided to. Blue is going to be set notation. Okay. So, blue. I just want to color code it so you can see it. Set notation is in blue. This is just x, a bar. You grab the same inequality. Okay. Then close it off with the bracket. Set notation, again, the bar means it is greater than or equal to, parentheses, greater than. Sorry, these are less than, I'm sorry. Less than or equal to, less than. If it looks like that, greater than, still parentheses, greater than or equal to, that is a bracket. So here, they're both open, so they're both open parentheses, negative infinity, comma, positive infinity, parentheses. Okay, now let's look at your range. Okay, please understand the range just refers to your y value. Again, this is the first problem, so I want to explain this in great detail. All right, you're going up and down. So if you go down, you go all the way to what? Negative infinity. Doesn't tell us to stop. What happens if we go up? It goes all the way to what? Positive infinity. Doesn't tell us to stop. So we will say the y exists in between negative infinity all the way to positive infinity. Okay? What is that in bracket notation? Sorry, set notation. We put our fancy bracket. We put the letter y for the range, the bar, such that y is greater than negative infinity, but less than positive infinity. And we close it off with the fancy bracket. Green for set interval notation, we would say that it is open at negative infinity, comma, is it closed or open at positive infinity? It is still open. So there you go. That it would be your answer. Okay? You just have to look up, down. Okay? Again, this one is just practicing the different notations. Okay? Let's look at 2. All right. So again, let's just repeat some information. The domain is referred to your x value. We are looking left and right. So let's look left. Oh, boom, tells us to stop. Look, tell us to stop. It stops at what? Negative 3. Good. And what happens if we go right? Boom, 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 boom. Keeps going all the way to positive infinity. So the inequality for x, the smallest is negative 3, and the largest, if we keep going, was to positive infinity. So x is x is greater than negative 3, but less than positive infinity. How does that look like in set notation? We put our fancy bracket. Okay, if you want to learn how to make the fancy bracket, think about a little like peak or an L, and you curve it up and you curve it up. So think about a C, and a like a arrowhead. Okay. All right. So this is x, the bar. You drop the inequality. X is greater than negative 3, but less than positive infinity. Close it out with the bracket. Interval notation. Okay, we are. Oh, I am wrong. Haha, check this out. It's closed here. It's closed at x is equal to negative 3. Do you see how it closes right here? So it can be negative 3, right? This is include. So it has to be include. So you have to be including the negative 3. Okay? Because when I do my interval, it's closed at negative 3. And it goes all the way to positive infinity. Why? Because it can be negative 3 at this point. Okay? Okay, it includes it. It includes negative 3. Okay, let's do range. Okay, range is your y value, and range is looking at up and down. Okay, we go down. Where do we stop at? Oh, we stop right here at negative 1. Okay, then we go all the way up. Oh, seems like we keep going to positive infinity. So the inequality looks like we can touch negative 1, so it's negative 1. It's x is greater than or equal to. Do you see here? It has to include the negative 1. Okay, but it has to be less than infinity, positive infinity. Okay, all right. So set notation, fancy bracket. Sorry, this is for range. I should not be using x. We should be using y. Okay. So set notation. This is for what letter? Y. Our bar. Drop in the inequality. Negative 1 is y is greater than or equal to negative 1, but less than positive infinity. Finish it by closing it in the bracket. Interval notation. Does it include the -1? Yes, it does. So we close it in a bracket, and we have infinity, and we know it always has to be open on infinity. Good. All right. So 1 and 2, I gave a very detailed explanation. So the other ones, I'm not going to go into much detail. Okay. 3. Let's look at the domain. Well, what happens? This is your x value. Okay. I'm going to write it again. All right, so let's look at it. We go all the way left. Oh, does it stop? Nope, there's no dot to telling us to stop. Nope, keeps going all the way to -infinity. What happens if we go to the right? Is there a dot telling us to stop? Nope, goes all the way to +infinity. So we could say x is greater than -infinity, but less than +infinity. In set notation, that would be fancy bracket. X bar, grab the same inequality from above. Interval notation. Okay. Is it open at -infinity? Yes. So it is a parentheses, -infinity, and +infinity. And we open these. These have to be both open. You cannot bracket. Remember, you cannot do this. Okay. You cannot do this. You cannot do that. Why? Okay. You cannot close down infinity. Remember that. You can't do this. This is bad. Okay, it's always open on infinity. All right, let's look at the range. Range is referred to your y value. What is our smallest y? So we keep going down, 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 out. Look, the arrow keeps telling us to go down to -infinity. What about here? Goes all the way up, 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 up. Keeps going all the way to +infinity. So what does your inequality looks like? Okay, so inequalities for the letter y. It exists in between what's your smallest, -infinity. What is your largest, +infinity. Putting it in set notation. Here's our fancy bracket. We can use the letter y. Here's the bar. Grab down the same inequality from above. Interval notation. Is it open or closed at -infinity? It is open, so we put a parentheses. Is it open or closed on the +infinity? It's still open. There you go. Okay. Yes, 3 and 1 have the same answer when it comes to domain and range. Okay. They might even have the same end behavior. Yeah, they might. Yeah, they kind of even do look like the same end behavior. Okay. Huh, this is interesting. 2 and 4 look the same. We'll see. We'll see if they have the same answer. All right, let's do 4 now. All right, domain. This is your x value. And we go left. Boom, 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 boom. Oh, we stop right here. This is when what? This looks like 0.2. Yeah, that looks like 0.2. So it goes from, it stops here. X stops at 0.2. And if you keep going left, and what happens if you go to the right? Oh, it goes all the way to +infinity. So x is less than +infinity, but greater than where does it stop at? 0.2. Again, it is greater than or equal to. Make sure you have the equal to, because again, because it includes, right? It includes 0.2 because the graph touches the 0.2. Okay, and what does this look like in set notation? Here's the fancy bracket. Okay, here's your x bar, 0.2. Bring the same inequality down here. Interval notation. Okay, is it open or closed at at 0.2? It is closed because look, the less than or equal to. Okay, is it open or closed at infinity? It has to be open, right? You cannot close down infinity. Good. Let's look at the y value. What is the smallest y value? Well, we can't go anywhere here. The y here is 0. Okay, that's the smallest y we could get. What happens if we keep going up, 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 up? You see the arrow? It goes all the way to what? Positive infinity. So we would say the inequality of y is less than, just less than, infinity, but greater than, what is the smallest y? 0 in our case. Putting this in set builder notation, our fancy bracket, we use the letter y for range, the bar such that y is greater than 0, but less than positive infinity. Close it out with the fancy bracket. Okay. Oops, I made a mistake. This should be less than or equal to. Sorry, greater than or equal to, and this is also greater than or equal to. Why? Because the graph touches 0.2, so it has to include 0. Okay? Okay? It has to include 0 because again, it touches the 0. Okay? So the interval, it looks like this. It's closed at 0, comma, how far does it go? All the way to positive infinity. Okay? That's how that looks like. Again, the intervals, they said that it was closed at 0.2 and 0. Okay, make sure you got that. This is for your x, your domain. This is for your y, which is your range. Okay. Tomorrow, when we talk about maximum and minimum, it's going to make a little bit more sense. Okay. All right. Let's look at 5. Oh, our good old parabola again. Okay. Domain is your x value. So we start here. Let's go to the left. Do we stop? Nope. The arrow keeps telling us to go all the way forever until you get negative infinity. What about if we go to the right? It doesn't tell us to stop, so we go all the way to positive infinity. So x is less than positive infinity, but greater than negative infinity. Put that in set notation. Bracket x bar such that x is less than infinity, but greater than negative infinity. There you go. That's how that would look like. Interval notation. It is open at negative infinity. And it is open at positive infinity as well. Okay, let's look at the range, which is your y value. What is the smallest y value? Go, 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 go. Oh, stops right here. 1, 2 at 2. So you stop here at 2. Negative 2, I mean, right? You see how it goes to negative 1, then goes to negative 2. What happens if you keep going up? Follow the arrow. 2, 3, 4, 5, so on, goes all the way to positive infinity. So your y goes from your smallest value is your negative 2. Okay, y is greater than or equal to, because again, it has to include the negative 2, but less than infinity. Putting that in set builder notation, our fancy bracket, we use y, the bar, such that y is less than infinity, but greater than or equal to negative 2. Close it out. Okay, does it include negative 2? Yes, so we put the bar, negative 2, the bracket, comma, is it open or closed at infinity? It's open, so we open it with a parentheses. Okay. 6. Let's take a look. Domain is your x value. Let's go to the left. Does it tell us to stop? Does it tell us to stop? Nope. Keeps going because there's no dot telling us to stop. Nope. Goes all the way to negative infinity. What about here? Keeps going. There's no dot telling us, so it goes all the way to positive infinity. So your inequality, your x, is less than infinity but greater than negative infinity. Putting that in set builder notation. Fancy bracket. X such that x is less than infinity but greater than negative infinity. And here's your set. Okay, interval notation. They're both open. Okay, you cannot close infinity down. What about your range? Your range is your y value. Okay, let's look at this. Okay, what happens if we go down? Oh, goes down all the way to negative infinity. What about if we go up? Well, stops here at 2. So the inequality, the smallest value here, it goes to negative 2. The largest value here was a 2. So your y has to exist in between here. Y can become negative 2, so y is less than or equal to 2. Here's the bracket. Set notation, I mean. Y such that negative infinity. Y is greater than negative infinity, but less than or equal to 2. Let's put in bracket or interval notation. Do we open or close? We open it at negative infinity. It includes 2, so we close it at 2. Okay? Because you can't go past 2 here, so we stop there. 7. I think this is a log. I think 7's in log. You won't see that until next year. So domain is your x value. Oh, this is tricky. What happens if we draw the arrow here? What's the arrow pointing? Goes down here. Ooh, this is very interesting. You won't be given some 7, right? So don't freak out. This is for your advanced students. There's actually an asymptote here. Okay. So it blocks here. The line never goes through. So here, the highest the x is going to go, right here, is x is equal to 0. It stops right here. What happens if we keep going to the right? X goes all the way to positive infinity. So the domain, it stops here at 0, goes all the way to positive infinity. And this is for what letter? This goes for your x, which is your domain. Okay, but it includes the 0. So it looks like this. How do you read this? X is greater than or equal to, and this one is x is less than. Okay, that's just what it means. So x is greater than or equal to 0, and x is less than infinity. Set notation. Okay, fancy bracket. X is here, bar, 0. X is greater than or equal to 0, but less than infinity. Let's put in interval notation. So we close it at 0, but we open it at infinity. Okay, your range, it is your y value. If we go down, y goes to what? Negative infinity. And what about if we go up, y goes to positive infinity. So what's the inequality? The smallest y you can get is negative infinity, and the largest y you can get is positive infinity. Okay, that is your y. Okay, you don't put the bar because you cannot touch the infinities. Here's a fancy bracket. Here's y, such that repeat the inequality. Okay, interval notation. They're both opens because it's negative infinity and positive infinity. So they're both opens at both values. Okay. Let's go 8. What is the domain here? Ooh, interesting. This is your x value. So follow the arrow. Goes all the way. Oh, keeps going. Look, the arrow keeps going. Goes all the way to negative infinity. What about we go to the right? Goes away to positive infinity. So your inequality, this is for your x. Okay, goes from negative infinity all the way to positive infinity. Okay, all right, less than, x is less than infinity, but greater than negative infinity. Put this in set notation. Here's the fancy bracket. X, that's the bar. You grab the same inequality from the top. Then you just close the bracket down. Okay, is it open or closed at negative infinity? It's open at negative infinity. It's closed at positive. It's also open at positive infinity. All right, let's look at your y value here. What is this? What is the largest? So we go up, goes all the way to positive infinity. What happens? We go down. Oh, it stops here at y equals to negative 2. See, stops here at negative 2. So the inequality. Okay, the smallest y that you have is -2. The largest y that you get here is infinity. Here's x. Sorry, this is range, so we use the letter y. Y is less than infinity, but greater than or equal to -2. Why is it greater than or equal to? Is because it can touch -2. Here's the set. Fancy bracket. Y bar. Drop the same inequality as before. There you go. Interval notation. Is it open or closed at -2? It is closed at -2. Is it open or closed on infinity? It has to be open. Okay, you can be closed at a number, but you always have to be open for the infinity. Okay, so there you go. You should sort of see a couple of things, right? The inequality and the set notations look exactly the same. Okay, the interval notation, you just have to make sure it's in a bracket. Okay, open or close. But there you go. Those are all your solutions for Tuesday, February the 11th.